In this problem, there is a sequence of real numbers with the certain rules of calculating every member of the sequence, and the question of the problem is which members of this sequence will stay in the same place after rearranging it in the decreasing order. When we examine the rules of calculating the members of this sequence, we understand that all members of this sequence are positive real numbers that are less than 1. Such numbers possess the following property. When such number is raised into power, the smaller is the exponent, the greater is the value of the power, and vice versa. This example illustrates this rule. When number 1/16 is raised into power 1/2, the result is 1/4. And when it's raised into power 1/4, the result is 1/2. Just based on this property, it's not too hard to realize that every even positioned member of this sequence is greater than the odd positioned member that immediately follows it. Also, all the odd positioned members in the beginning sequence are increasing their values. So in the target arrangement, they need to be reversed, while the even positioned members are decreasing their values. So in the target arrangement, they are in the same order as in the beginning arrangement. As shown in this diagram, the last even in the position 2010 is less than all the evens, and the last odd in the position 2011 is greater than all the odds. At the same time, the even in the position 2010 is greater than the odd in the position 2011 that immediately follows it. From this, we can conclude that all odds are less than all evens. What we have just formulated is the key point of this problem. From now on, we can forget all about the real numbers and their powers and concentrate on counting the positions in order to answer the question of the problem. In fact, we can formulate a completely new problem that is equivalent to the original problem. Imagine that the musicians of a very big marching band are standing in a lineup in the positions 1 through 2011. The trumpet players stand in the even positions 2, 4, etc. up to 2010. The drummers are standing in the odd positions 1, 3, etc. up to 2011. Suppose that all the drummers make one step forward as shown in the first diagram. Then turn to the left, to their left, and march toward the end of the lineup. All the trumpet players make the necessary steps to their right, our left, to occupy the positions 1 through 1005. The drummers then make a U-turn and move to the positions 1006 through 2011, so that the last drummer becomes the first one and the first drummer becomes the last one, as shown in the diagram number 2. What are the positions of the band musicians that stand in the same position where they were in the original lineup? As we have said before, all the trumpet players made some steps to the right, so the trumpet players have no chance to return to the place where they stood originally. So only a drummer has a chance to return to his original position. Let the position of such drummer be N. Then M which is equal 2012 minus n, is the distance between this current position of the drummer and the end of the lineup. Then m is that drummer's number among his fellow drummers before the U-turn. Then the drummer's position in the original row of all marching band musicians was 2m minus 1, which is the formula for an odd number. Substitute 2012 minus n for m in this formula, and this gives us the equation for calculating n. This equation has only one solution. N equals 1341. The answer is C.